Let's talk about how to factor trinomial squares in the form x²+Bx+C. This is important especially in reducing rational expressions, finding limits, derivatives and integrals and more. The standard form of trinomial squares is ax² + bx+c. In this case a is 1. Example x² + 6x + 8. Both the last and the middle terms are positive, so the factors are positive. If we have 8 equals 1 times 8, then 1 plus 8 equals 9 and 6 is not equal to 9, so this is not the factor we need. Then if we have 8 equals 2 times 4 and 2 plus 4 is equal to 6 and this is the middle term. So this is equal to quantity x plus 2 times quantity x plus 4. Both the middle and the last terms are positive. Next x² - 8x plus 15. The last term is positive and middle term is negative, so our factors must be both negative. If we have 15 equals 3 times 5 and 3 plus 5 is positive 8 and negative 8 is not equal to positive 8. If we have 15 equals negative 3 times negative 5 and negative 3 plus negative 5 is negative 8 and is the middle term. So our final answer is equal to quantity x minus 3 times quantity x minus 5. Another example x² + 3x - 18. Here we have a positive middle term and a negative last term. The factors have a positive in which it has bigger absolute value and negative with smaller absolute value. So we have negative 18 is equal to positive 6 times negative 3, and if you add positive 6 plus negative 3 this is equal to positive 3, which is the middle term. So this is equal to quantity x plus 6 times quantity x minus 3. Our last example is x² - 5x - 24. Both the middle and the last terms are negative, so our factors have a negative with greater absolute value and a positive with smaller absolute value. So we have negative 24 is equal to 3 times negative 8, and if we add positive 3 plus negative 8, we have negative 5, which is the middle term, so our final answer is quantity x plus 3 times quantity x minus 8. These are the 4 cases of factoring trinomial squares in the form x² + bx+c. For both the middle and the last terms are positive, the numerical factors are all positive. For negative middle term and positive last term the numerical factors are all negative. For positive middle term and negative last term the numerical factors have a positive with greater absolute value and a negative with smaller absolute value. For both the middle and the last terms are negative, the numerical factors have a positive with smaller absolute value and a negative with greater absolute value.